Okay, so we're going to do a batch fit of these monthly uh, price changes, monthly changes in index prices adjusted for inflation. Now, I'm going to copy this down here so that these names will get, okay, and remove that. So these names will get associated with each column. Okay, so here we highlight this way, okay, and do a time series batch fit. Okay. Now the data goes from N9 to 390, and we can give a name for, so 5 city adjusted price. Okay. Now models to fit. Okay, so I just take the auto detect. Okay, and then the report of the fit. We can select some options. We can include correlations, include detailed report worksheet of each fit. Okay, so you're going to get the detailed reports for each fit, and then there will be a summary report. Now, all of that can be either in a new workbook or after the last used column in the active workbook, okay, or a query for starting cell that you can provide where to put the output. Now, we're going to keep a new workbook. So now when we click fit, it's going to fit and put all the results in a new workbook. So click fit. Okay, so now we have the new workbook. Okay, and now the individual sheets are named real San Francisco, real Boston, and so on. This is the reason why I moved the names to this row. So these names will get associated with each column, and those names will be automatically inserted to the sheet names. Now, if you go into each sheet, gives you the different models that were tried and the model that was selected. Best fit, ranked by Akaiki information criterion. Okay, so we have that for each city, but this is the sheet that is of interest to us. So again, it gives you the name of the city and then the range of the data. So it then gives us the model that was used to fit and the corresponding AIC value. And here you have the function for 24 months. Okay. And then we have the correlation matrix that the correlation values are inserted here. Okay. Now these are the functions that at-risk has generated, right? The simulated change in price for the future time periods. So we ended with the last one being 11/1/2018, right? So this will be 12/1/2018, and then 1/1/2019, and so on. So this is the simulated daily change as a percentage of the price. So what we want to do is to now run the simulation. So these prices or monthly change in price will be simulated. So say we run 10,000 times, we're going to have 10,000 results. Now we want to use that to try to predict what will be the price after 12 months. Okay, so let's say 12 months, and we're going to assume that uh, we we're going to do the calculations on an index basis. So let's say that $100 is invested. So that stands for a index value. So in each of these cities, we invest $100. Then what will be its value after the first month? So it's going to be that value. Now I'm going to the initial value sorry. So the previous value times 1 plus the change. So real San Francisco, it'll be that. Okay. So we can copy down for 2 through 12, and we can copy across for different cities. So we close parenthesis and press enter. So that would be the price or value of that $100, okay, in month 1, okay, and the corresponding value. So now we go this way. So now we have, okay, let's all right. All right. Next, we want to see whether we made a loss or not. Okay. So if we compare this value at the end of 12 months with what we started out with, okay. So if we say if that value is less than what we started out with, right, then yes, we made a loss. Otherwise, there was no loss. Okay. All right. Now we want to do a couple of things. Okay. One is the probability of loss. Probability of loss will be the mean. So this is going to be either 1 or 0, depending upon whether this is less than that or not. So there's going to be a bunch of, when you run the simulation 10,000 times, there's going to be a bunch of zeros and ones. So if we take the mean of that, that's going to tell us the proportion of ones. Okay, so the mean of that, that's going to give you the proportion of ones, and that will be our probability of loss. Okay, and we can also count how many cities had a loss. So number of cities with loss. So that's going to be simply the sum of that. Okay, and let's make that into an output. Okay, so we'll generate a plot for that. Okay, all right, so now we can run the simulation. So make sure that this is automatic and fixed seed. Okay, so now we can run the simulation. Okay, so now we have the probabilities of loss in each of the 5 cities, and here we have a plot of how many cities we will face a loss. Okay, so uh, between 0 and 4, 90%. So there is a 95% chance that there will be 4 or less. If you bring it here, so there is a 55% probability that uh, 2 or less, or in other words, 45% probability that there will be more than 2 cities with loss. Okay, let's put it back here. Okay, let's copy the graph and paste it here.